Okay, this will be part 3 of our Unit 4 review. First video had 1 through 4. Second video had 5 through 8. So we're going to turn it over on the back and do 9 and 10. So for table number 9, they're asking us to do a line of best fit, and they want the equation for it. So this is where we're going to use stat. Remember that we never enter the actual year date. We enter which year it is. This is our beginning year, so it's 0. That's 1 year later. Another year later, another year later. So it's which year are you in. So they gave us a hint here to use 0, 1, 2, etc. for the years. So that is what I need to enter into the table to get this information. So here I am at, let me get out of that. Let's go to Stat, Edit. I need to clear out the data that's here. So remember, I go up and I highlight the column, and then I'm going to hit the clear button here and then hit enter so that it clears it out. Never use the delete key. You are clearing out this column. You are not deleting the column. So here we will put in the X values into L1. Then we'll put in the Y values in L2. Notice I had 3 that were the same there. 25.5, 25.9, 26, 26.2, 26.5, 26.7, 26.9. Okay, so now we go back to stat. We're going to calculate item number 4, which is linear regression. That's this one right here, and hit enter until it calculates it. So what we're going to do is, for the purposes of what we're doing, we'll just round to the nearest hundredth. It may be that they round to the nearest tenth. You'll just have to look at your answer choices to see which it is. So here I rounded to 0.19, and I used 24.95 for the y-intercept. Notice that the correlation coefficient is very close to 1, so this will have a correlation that is a strong positive. We know it's positive because there's no negative sign in front of it in the calculator. Okay, for item number 10, they've given us a graph, and they're going to want us to estimate when it is 17. So let me clear out the calculator real quick. And let's see what happens when we are estimating this for 17. So what you would do is take and enter these into L1, and the Y values into L2. Okay, so let me go ahead and do that. So we go to Calc. Again, we're going to clear each of these columns. We're not deleting them, we're just clearing them. So these are the estimates that I came up with. Your estimates may have been different, and more than likely are different, and that's okay. We should be close to the same values. When we do some rounding, we should be within the same ballpark. We shouldn't be off by a whole lot. If we're off by a whole lot, then we need to look at it. So the first thing I need to do is calculate what that equation is going to be. And here we have a slope of 5.12 and a y-intercept of negative 5.07. So I'm going to write that down. Y equals 5.12x minus 5.07. Notice that the correlation coefficient is closer to 1 than it is to 0. It's definitely bigger than a half, so this would be a strong positive correlation. So now I'm going to go to y equals and enter in the equation that I was given. So that's the 5.12x minus 507. And then I have 2 options for the table. I could go to the table and just go down to 17, or I could do the table set and tell it to ask, and then when I go to the table, I'd have to type in 17. Either way, I would get 81.97, so probably approximately $82,000, which puts it somewhere along in here, which is where we would expect it to be, somewhere between 75 and 100, because it looks like things are going up. Okay, problem number 11 wants us to describe the transformation from the parent function to this function. So what we had is we had our slope decrease because it went from 1 to 1/4. So we have a value less than 1 for our slope. And our y-intercept was an add 2. So a decrease in slope means that it becomes less steep. And adding 2 means it shifts up the y-axis 2 units. So that would be our transformation. It would become less steep and it shifts up 2 units. For number 12, they simply want us to write a new equation. And to write that new equation, they want us to take the equation that we're given and double the slope and change the y-intercept to 6. So we'll just use g of x for our new one. If I double the slope, I'm doubling 3, so 3 becomes a 6. And instead of a -5, I'm going to change that to a positive 6. And there's my new equation. So this is part 3 of the Unit 4 review, and we'll have our last one here in a few moments.